I'm going to talk about machine learning and AI and its application in the future, or maybe even the present, of e-marking. There have been quite a lot of mentions of this through the day, so hopefully this will bring together a number of those topics. It's quite a wordy title. I'll try not to make it quite so dry as it sounds there. But I'm going to do a little bit on what machine learning and AI are. I'm going to talk about cars, because most presentations have done. I'm going to introduce a 5-level model for the adoption of automation in e-marking. You should all have in front of you a copy of that model, which has been kindly delivered during the break. And so I'll go through that and give some examples, and then maybe even give some thoughts to quite when we might see some of these levels of marking. So let's just start with what are machine learning and AI, and I'm not going to talk about neural networks or anything complicated. Machine learning, systems that learn how to perform a task without being explicitly programmed to do so, that can self-learn, that can be trained through repetition and high volumes, and ultimately become a means to achieving artificial intelligence, which in turn will give us computer-based automated systems that will be capable of human-style judgments and applications, one of which, in our context, would be the marking of students' work. So is machine learning suitable for marking essays? I'm being quite clear that I'm talking about essays, long-form answers, using computers to mark multiple choice or to mark OMR bubbles has been around for a very long time. That's quite easy. That's not really what we're looking at here. So this is in the context of long essays, things that are really at the moment require a human to interpret and mark accurately. And can we do anything useful with machine learning? So can we? Well, if you talk to Google or Microsoft or any experts in this field, they'll make the point that all of this starts with good data. You really need to have a good data set. And I think in the field of assessment, we really should have that. And that's because ultimately we're in charge of setting the questions. So we know the context, we know what it is we're looking for. We control the format. We specify how all of these responses should be written or typed or gathered in. And because of the volumes at which exams typically operate, we should have many, many instances of a response. We should also have the benefit of many previous responses from previous years. So data-wise, we should be in a good position to adopt machine learning for the marking of essays. However, there are some big gotchas, and I'll get this one out of the way straight away. We're not really in a position to do this with handwritten responses right yet. You can use intelligent character recognition to try and interpret handwritten text, and in some contexts it's good. To try and do it accurately enough to mark the essay of a stressed candidate writing many, many words in a short period of time, it's not there yet. There are some great new APIs that are coming out that provide handwriting as a service, handwriting recognition as a service, and it may well be that they get good enough that this has a potential in the future, but I don't think we're quite there yet. So that's one. The other is that writing a machine learning model and working out how to interpret and mark is not easy. It's a very specific skill set. It is a good example of a modern skill that people will be learning. I think there'll be a lot more people that can do this in probably the fairly near future, so that's less of a concern. Good news, I think, for most of us in the room, domain knowledge will absolutely be essential. In order to make any of this kind of stuff work, you have to know what is a sensible question to ask and what does a good response look like so that you have any chance of training a model to identify that. So we're still going to need psychometricians and academics for a long, long time. And lastly, the acceptance, and whether it's acceptance from candidates, from parents, from the establishments that will be running these tests. The idea that a machine might be marking a human's work will take some time to adopt, which strangely takes me on to a model to do with cars. So this is from the Society of Automobile Engineers. It was published a couple of years ago, specifically to help people in the context of talking about self-driving cars and automation. Lots of talk, lots of things going on, but what they wanted to do is define a model through a number of stages, from level 0, where we used to be some time ago, where a human drove the car, right the way through to level 5, we have a fully autonomous car that drives itself and a human can't do anything. And this was helpful because it gives common terminology and language, but it also shows a transition over time. So that's what's been used in the world of cars. What I'm presenting today, and this is the handout that you all have, And it's not easy to read on here, but I'm going to zoom in, and I'm going to go into detail on each of these. And Mel told me she's just tweeted this as well, so there'll be a digital version available too. But this is a model trying to do the same kind of thing for the automation of marking. And we start from level 0, which was already the past, which is human-only marking. We don't really do that anymore. On level 1, you start to use machine learning and AI to improve processes. It's in the background. Markers have no awareness of it. It doesn't directly affect marks, but it makes things more efficient. Level 2, I think things start to get interesting, and that's where you're using machine learning and AI to augment the marking experience, to make it faster, more efficient, maybe more accurate. At level 3, we're starting to tentatively say, I think I can identify some things, I think there's some marks here, maybe this is the score, but it's still very much human-led. The human marker is the expert, and they're being helped by the AI. At level 4, this is the sort of classic model for machine learning. We have a human-primed data set. A lot of things have been marked manually, and that's trained a model that means we can automatically mark high volumes beyond that. And level 5 is potentially the nirvana or the end of the world, depending on your perspective on things, where really we've just got a mark scheme and a very clever AI, and you send it a load of content and it marks better than a human can. So that is a real rattle through the model. Like I say, I'll go into that in a bit more detail now. So skipping level 0, because we don't need to. Level 1, process improvements. As I said, this is automating and making things more efficient. And some examples of this would be just analysing a lot of the data that comes in as we go through the scanning processes and the marking processes. As we've moved to e-marking, digital marking, there's a lot more of this data is available. We can learn from that as we go. We can learn from previous sessions and make all of that more efficient. We can do some clever things using machine learning already there. So we've done work using intelligent character recognition where we don't try and interpret the whole of a candidate's response, but we can identify the number they've written in the margin, so we know that they've answered question 2 in this particular part of a response, and so we can take a marker straight to that particular part. They can mark the right thing. They're not having to look through 10 pages to try and work out where a candidate answered a response. Similarly, we don't do this currently, but I know that this can be used elsewhere, using things like sentiment detection. So where you're receiving support queries, maybe by email or by telephone, you can identify how stressed or upset or angry a person is, and you can modify how you respond to them and how quickly. So there are examples at level 1. So moving on to level 2, and as I say, I'll try and spend a bit more time on level 2 and 3, because I think that's where we've got the most potential. So yeah, this is the first area really where we'd expect a marker to get exposed to machine learning and AI. They're AI-supported functions that a marker will see and interact with, but it's not persuasive. It isn't, at this point, trying to up-to-date my Apple software. As well. So the AI at this point isn't saying, I think this is the answer, or assigning marks. So some examples of how this might work. An intelligent chatbot, an assistant that works with you as you're marking. As Ian highlighted earlier on this morning, pulling out text from videos or audio files so you can do clever things with it. And we'll look at some examples of these in a moment. Video bookmarking. We've talked about marking multimedia and how important that will be. Marking very large or long video files can be quite challenging. We can look at using AI to make that easier. Using technology like face blurring to protect the identity of candidates. Basic things like analysing the quality of the text and the grammar in the response, through to things like detecting plagiarism. So they're all examples of what we'd say is the augmentation of marking. So this is one quick example that one of our teams have worked up. They've done this using the Lewis framework from Microsoft, which is a framework that allows you to relatively easily create a chatbot or an assistant that can work with you while you're marking. This hopefully solves a few problems. I think for some markers, using chat and IM is a very natural way for them to interact. This is much better than leaving the context of the exam to go off and use a separate site or a separate tool to contact support. It uses natural language interpretation, so they can ask a question in a way that works for them as a marker. We can understand it and guide them, take them towards the right help and guidance that they need. The bot will learn over time, so its ability to identify a question and map it to the right answer will get better over time. Where there's some nice things you can do on top of that. Where this doesn't know the answer, at that point we can escalate to human support. That can all happen seamlessly within a chat conversation. And then going further forward still, because this is running, this can be running in the background while the marker is marking, perhaps more like the digital assistant that you have at home that learns about you and your habits. It can maybe analyse how you're doing. It can start to suggest that you might want to add some more to your cue, or you might want to mark in a different way, or just to help run that marking process. So that's one example of a chatbot. Multimedia, we've talked about quite a bit. Before I go in and show you one of those POCs, I'd just like to show you some of the tools that are available now that make doing this a lot easier than it used to be. So these are some screenshots captured using some of the Google APIs that they provide for analysing video. And this isn't directly relevant to marking a piece of student work, but hopefully as I build this up, you'll see how it can be. So what they've got here is a video that's been uploaded, and as it's processed through the video, it's identified, using machine learning, the different items that it finds. In this case, it's a nature video, and it's quite confident it's found a tiger, and there's some nature, and possibly it's a tourist destination, or probably quite a dangerous one if the tiger's there. So being able to go through a video and see what you think is in there. And as well as identifying what you think is in a video, you can bookmark where in the video that thing appears. Another example, this is a Microsoft API. Ian showed pictures of a similar thing before. I know a lot of people like to use this to see if it can guess their age properly. It's actually doing some really nice things in the background. What this can do is pick out all of the unique faces within a video and assign them their own unique ID, and then combined with some of the other points here, we can see where were all the times at which that particular face appeared in a video. And if you take all of those technologies and many other APIs that build on machine learning, you can hopefully do some clever things. So this is one of the POCs that we put together, proof of concept, taking a number of those. And what we did, we took a video of some candidates that were doing the English language spoken test, and we processed all that video using some of the Microsoft cognitive services. We pulled out all of the words that the candidates spoke, and we created a transcript of those. So you've gone straight from what was originally just a video to now you've got a transcript that you can search through, and you can annotate and assign marks to. But you can also search through that transcript. You can look for keywords, the things the candidate should have been talking about. We've been able to take the transcript and then apply it as subtitles. So you could watch this full screen with subtitles on if you wanted. More to try and throw in as many features as we could, than because it's really relevant, but we could also then translate that on the fly using a Google Translation API. And yeah, do lots of nice things with that transcript. The other thing we can do within this particular example, where a marker would normally mark a piece of student's work for a High 6 exam, they would do that anonymously. They wouldn't know who the candidate is. If they're having to mark a video, it's unlikely they would necessarily know who the candidate is, but there might be some cases where actually it's better to preserve the identity of the candidate as well. And so it's quite easy to just take the video, put it through a cloud service that uses machine learning and identifies where the faces are and can blur them throughout the video. And then combining the identifying faces and where they were within a video, we think one of the good use cases for this will be marking things like a theatre performance, or perhaps some PE recordings where you have multiple candidates within a single video, and that video might be quite long. And if you're tasked with marking the performance of candidate 3, we can use this system to take you directly to the 3 or 4 minutes out of an hour where candidate 3 actually appears. So very similar to that concept of bookmarking, but we're doing it within multimedia. So this is augmenting. It's making it faster and easier for the marker. It's not telling them what the answer should be, but it's using machine learning. Other things you can do, and some of you I'm sure will be familiar with this, there are services that you can use where when you have the digital content, you can send it off to do plagiarism checks. So Turnitin is quite a famous one. Blackboard have a similar. So if we have digital content that's been submitted, whether it's coursework or exams, that can be immediately reviewed to see whether there's been copying that's gone on. Now that's been around for a while, and you can do that with essays and coursework. But because we are combining, because we could potentially combine this with the capturing of text from videos, you could even go further and identify whether, when candidates are on, say, a spoken word language test, can we send all of those transcripts off and identify that in one particular centre, a lot of candidates all gave very, very similar answers, and perhaps they've been given a script and there's some cheating going on. New capabilities. So moving on to level 3, which we call tentative marking. So at this point, the AI is genuinely trying to assist the marker with working out what the right answers should be and what the marks might be. The marker is still very much in charge. The marker decides what the right response should be. But at this point, the AI might influence the marks that are awarded. So some examples of that. Where we have a good mark scheme and you need to have written about certain things or in certain ways, we can go through and use this technology to identify and highlight those areas within a response. We can go through and create perhaps that preliminary mark and propose what that might be to the marker. They're still in charge. Flag similar responses that are marked differently. So within RM Assessor and within other systems, there are quite well-developed quality models with things like seeding, the mystery shopper that Deborah talks about, where we identify perhaps where people are marking out of tolerance. This is another technology that could be used to spot perhaps automatically that one response was marked very differently to others. This one, I think if this can be made to work, I think this is genuinely very, very exciting. Grouping together very similar responses for mass marking, I think would be a slightly better way of describing it. So if you have 20,000 responses, we can go through those in advance, and we can identify that 400 or 500, maybe 1,000 or more of those responses are really, really similar. And it's probably slightly better for shorter responses, but they're all broadly the same thing. They're saying the same thing within a level of tolerance that we're comfortable with. Could one marker then assign a consistent mark to 500 questions in one go? So maybe there are efficiencies there. And another really nice way of using this is effectively to get inexpensive double marking. So you're still marking human first, but we go through and do an automated second pass, and again flag anything that was marked perhaps wildly differently until we gain more and more confidence. So that's tentative marking. So this is another proof of concept that we've put together recently to try and see how some of this might work. And this uses some APIs from IBM, from some of their Watson services, and also Wikipedia and Google's natural language analysis. The first one is quite basic. It's gone through the text, it's found some interesting things that candidates have written about, and it goes off to provide the marker with some additional reference information about those subjects, so probably not as directly relevant. This second one, though, I think is much more so. Here, the candidate's been asked to give some advantages and disadvantages, and so they've done that. But in the mark scheme, have they given just simple statements? Have they given actually clear advantages and disadvantages, or have they given many advantages and disadvantages? And what we were able to do is to go through and analyse these sentences and say, are any of these advantages or are any of these disadvantages from the way that the sentences were structured? So we don't know definitively if the candidate got it right or not, but for the marker, we can quickly take them and show them that there were examples of those, and we can suggest that, yes, this looks like it's probably a level 2 kind of response. That's tentative marking. So level 4, human primed auto marking. I think when we've talked about machine learning and the automated marking of essays, this is typically what we've tended to talk about. So this is using an AI to definitively assign the marks, but to do that using a lot of priming and training of a data set. And that's to ensure, as we've said here, that that human priming makes sure that the marking carries the weight and the significance of qualified markers who've said this is what a good answer looks like. And I guess the benefits, I would hope, are really obvious. You will be able to mark much larger volumes using less people. It should be faster and less expensive. The AI overall should then give much greater consistency in how it marks. Just pointing out one of the challenges, we're not talking about marking 10 or 20 to train a model like this. It's always going to be, or for some time, it will be in the thousands. And so for some responses, that could well be as high as 25% of all of the responses still have to be human marked. So it's great, it's an improvement, but it's not going to magically reduce the workload to nothing. And then I think once you've got to this point, you've almost gone through a kind of a neat transfer from where we were at level 3, where you can use your machine marking effectively first. That does the majority of cases. And the double marking then is pretty much just human review of all of those responses where the AI is less confident, and you can set what those tolerances are, and perhaps those ones where you're less sure about it or it's much nearer to a grey boundary, they're the ones that go off for a secondary human review. So, I've talked about this as potentially being something in the future, but there are technologies that do this sort of thing now. So ETS have their e-rater product, Turnitin have expanded from doing plagiarism detection to doing auto marking. Cambridge English have their write and learn service. Pacific Metrics have a machine learning as a service or automated marking as a service platform called Craze that does that. In all of these cases, they do work, but they're not really being used for high stakes exams. They work quite well for short responses. They're not yet suitable for longer responses. And so I've been trying to work out why that is, and why, other than, why it is that in most conversations where this sort of thing has been talked about, that the full machine marking of essays has always been about 10 years away, but more recently it seems a lot nearer. And so why is that? And I've used this one slide from a Google Cloud conference that I attended recently, because I think to me, it indicates why we haven't in the past and why we will in the future. Probably not completely intuitively straight away, so let me just explain through. James mentioned it actually. On the left, Google are making the point that you can use their platform, and you can do it with Microsoft, and you can do it with Amazon as well, and you can use open source machine learning engines, and you can write your own machine learning models and write your own algorithms. And so you could write something that's really specific and tailored to your particular questions that you wanted to mark. But you're writing effectively a lot of plumbing, you're building an awful lot of the service yourself. The expertise to do that is immense, and it would be quite hard to keep that up to date and to change that as your questions change and things over time. So it's getting easier and easier to host it, and that's one of the main things Google are offering here. And if you have something really niche and specific you want to do, then it probably still is the right way to go. But it's always been hard, and that's why this has always been about 10 years away. The big thing for me, and the reason why I think this is now becoming something much, much nearer in the near future for us, is this ability to use machine learning and AI as a service. So Google, Microsoft, Amazon, they've built huge parts of their entire business on getting really good at doing the stuff on the left to analyze vast volumes of data for their own products and services. And what they've started to do in the more recent years is to offer those underlying building blocks of their own service as a service that you can use. So you go through some examples. You can call Google Services, you can send it your content, and it will do the work to tell you what was in a video. It will analyze the speech and pull out all of the words. It will process all of those paragraphs of text using their natural language API and give you lots of useful information about it. And you, as an awarding body or a supplier like ourselves, don't have to work out how to do these incredibly difficult things, because some very, very clever people are doing it for you. So Google have theirs. Amazon, lots of very, very similar things that they do. They'll also host TensorFlow. It's open source, and plenty of other open source models. Microsoft, they've branded theirs as their cognitive services. They have a wide range of these APIs. And none of these are the automatically mark an essay API, but a lot of them cover things like language and video and all of these kind of resources that we're trying to mark. And the speed with which these are being published and the speed with which these are being updated and the power that they provide is going at that kind of exponential rate that James Leonard mentioned in the previous talk. And so my feeling is that by building on these, that's where we're going to see the quantum leap that makes the automated marking of essays a lot more achievable. One quick gotcha that has come up in some conversations that I've had with people about this, though. The fact that these APIs keep improving and changing and are building on other people's knowledge is I think, in some respects, a really good thing. But one challenge we might have to face is that if you send a piece of work through to be analysed one day, and then you send the same piece of work through on a different day, you might get a different response. The language might be translated differently, the boundaries in a video might be analysed differently. It might be better, but you won't have consistency. So there's a lot of really good stuff, but also some new challenges for us. So I don't have a full working demo of this, but I did have a go at seeing what I could do using some of those APIs. And so I took an essay that my daughter wrote the other week, and I did check last night. I have her permission, copyright, to use this. I'm not sure she entirely understands what I'm doing with it, but she wrote about the Normans. So she's written it. Fortunately, she wrote it in an Office application, so we have some digital text. It's not handwriting. And I took that to the Google Natural Language API and just copied and pasted it and saw what you could get out of it. And again, none of this is a machine-marked version of her essay, but they're all really interesting views of what you get out of those APIs that we can then build on in our context of assessment. So here's her essay at the top. The API has gone through and it's pulled out all of the entities, all the things that she wrote about. So we've got some people, some places, some events, and the API knows about each of those. So it's classified them all and it provides those back to the software developers that are then going to do clever things with it. So we've immediately learned about whether the candidate has written about or covered a lot of the topics that you needed them to. The API has also gone through and it's analysed a lot of the sentiment. I don't think this is as immediately relevant, certainly in this particular essay, because it wasn't a particularly emotive essay, but it's capable of going through, and in the example I used previously, where you might be looking for advantages and disadvantages, pros and cons, some of the sentiment analysis can really help you to identify what type of response you might be looking at in each particular line or paragraph. And then lastly, and this is only a snippet because this just went on and on and on to explain it, it's gone through and it's analysed all of the different aspects of the way that she's constructed the sentences in a way, and I'm not an English teacher, I don't fully understand all of the things that are being shown here, but there is an awful lot of useful information for you to be able to then build on top of that and automate and do clever things. So I think this new world of APIs and AI, machine learning as a service, is what's really, really going to take this forward. So I think that will allow us to achieve level 4 marking in a way that has always been about 10 years away, but I think it's going to happen a lot faster. Level 5 then, kind of the equivalent of the fully autonomous car, is a really interesting one. That we've classified this here as being absolutely fully automated. All we would do is provide this with probably a fairly detailed marking scheme, but a marking scheme. Beyond that, it would be given the content, and it would need to be able to mark as well as the average marker, human marker, or better. And at that point, it's the sole marker of the examinations. There's no human intervention required other than, I guess, extreme QC type issues. So fully autonomous, no humans, primed by mark scheme only, accurately generating a mark. And I think it'd be really interesting to get people's views on whether this is inevitable or whether this is impossible. We've had some interesting conversations during some of the breakouts. It's easy to look at the rate of change in technology and some of the advances that we saw earlier and see that, yes, this is absolutely inevitable. But ultimately, can we really recreate what a very intelligent human marker can do to a point where people will actually accept it? It's really hard to know. But I think what we're hoping by introducing this model, it allows us to talk about the different levels, and perhaps over a period of time, because there are a number of these that are not controversial, and I would hope that a lot of the things you see in level 2 and 3, very few people would argue that having those available to a marker would be a bad thing. But as we do more and more of those and build on them and learn, it will get increasingly easier to start providing tools at a sort of level 4 quality that people can see are actually good enough and are confident enough, and over time that might become more accepted, and maybe we'll get to level 5. So I'm going to be brave and put some dates on those. I have spoken to John and to my boss, and so these are my view, but broadly I think we're all in support. So level 1, we're already there now, we're doing these things whether we even realise it or not. Level 2, augmented marking. it's been really great to put those proof of concepts together. Because of the kind of services we're building on, that's a very fast thing to do. And you can get some really good results very quickly. So we're quite confident that we could start to put some of those kind of products and features certainly into RM Assessor, and I think you'll see that from other people as well, as early as now, next year, 2019. Going a little bit further, starting to do some of that tentative marking and helping to inform you on what the right marks might be, also probably isn't that far away. To get to level 4, the human primed auto marking, I think probably 2020, 2025 feels about right to me. We've also had conversations in some of these breakouts about where these things will happen. I don't know that these will happen in the UK on those timescales. I think they might happen in other countries where they don't have as much legislation or as much legacy, and perhaps are developing at a rate which allows them to bypass a lot of the history and challenges that we have, and they may get there sooner. And then finally, autonomous auto marking. Again, asked a few years ago, we'd have probably said it was much, much further out. Having seen some of the recent progress and continue to draw analogies to cars, and I'm still not 100% sure that works, but I think we're still probably talking about 10 years away, but we're talking about something 10 years away that's even more advanced than we had before. So that's the model. Happy to take any questions, or to hand over to John to wrap up. Yeah.
So you're in the fully automated one then. What is the machine learning from? Just learning from the previous years or other questions. So it needs to learn. It needs examples to learn. And in level 4, it's learning from human whether it's getting human feedback or the other way around, it's seeing human examples and learning from human examples. How is it learning in level 5?
So I think you either go down the Skynet route, and Shumit would tell me off for that, where you assume that you have a completely sentient AI that can properly think. I don't think that will be the answer. I think we will have built up models based on many, many years' worth of responses, and we'll get very, very good at how we write our questions and how we write the mark schemes and the models that go into that sort of automated marking. We'll essentially have done enough previous training that it just won't need training per response. It's my thought off the top of my head. Okay, well, if there's no more, I shall hand over to John.